Hi everyone, my name is Chouhan and welcome to my YouTube channel. So in this NLP series, now we'll be looking into NLP with deep learning. So we'll be looking at into the first deep learning neural network model. The first one is the recurrent neural network, but we'll start with feed-forward neural network and see the feed-forward neural network is transformed into recurrent neural network or RNN. So in the earlier video, we have seen that how the feed-forward neural network is. And here we have a simplified diagram of this feed-forward neural network. Basically, we have input layer, and then and then we have the output layer, and in between we have the hidden layers. So we have represented that using a simplified approach here. So let's start with an example. Here we have a sentence. How are you? So this is our input sentence, and we will process this sentence using recurrent neural network. We'll see how the recurrent neural network will process this sentence. So we won't be able to pass the whole sentence at once. We need to pass the each of the token one by one. So first we'll tokenize the sentence or the text. It can be paragraph or whatever. First we will tokenize the text into words. And for this sentence, we tokenize into three words and one punctuation mark. Okay, so we have how, are, you, and then the question mark. If you imagine a simple feed-forward neural network, we'll have an input, we'll have then some hidden layers, and you'll get some output. So here we have shown that we are passing this to token how. But as you know that we won't be able to pass the token as it is. We'll need to first get an embedding of this token. Obviously, we need to represent this into a numerical form. Then only we'll be able to pass it. So I have ignored that for in this explanation, but you can assume that there are some kind of technique here where with which we have encoded this information into a numerical form, and then we are passing this token into this feed-forward neural network. So let's assume this is a feed-forward neural network for now, because it looks like one of the feed-forward neural network. So in feed-forward neural network, you'll have the input layer where you provide the input, and then you'll have the hidden layers where some calculations will happen, and you'll get some output. Okay, so we have passed this word or token how through this feed-forward neural network, and we got O1 as the output. Now we need to process the second word R. So what we can do is we can pass the R to another neural network. So we are passing this R through another neural network, okay, and we are getting the output O2. But along with this vector representation of R, we are also passing the output we got from the first token. So we are also combining the output O1 with the word with the token R. So what we'll do is we'll combine this O1 and R and tokenization of a word R, and then we'll pass through the hidden layers to the neural network. Okay, so we'll pass through the neural networks to get an output called O2. You'll see that in the neural networks earlier it was empty. When we passed how, it encoded the how. So you can see the color is blue here. Now when we are passing R, then for both the word we have some kind of information present in this hidden state in this hidden layer. Okay, so we have encoded information from both the tokens now in this hidden layer. So now we'll process the next word, which is U. We're passing the word U as input to this neural network along with the output O2 that we got from the second token. So the O2 will have the information from both the tokens, first and second. Now we're combining the output O2 with U, and we are passing it through the neural network. We are getting the O3. We'll see that the O3 will have information encoded from all the previous tokens. So O3 will have the information for how, R, and U. So we can see that in this circle as well. We have information from all the three tokens here. Now we'll process the next, which is the last token as well. This is the question mark. So similar to before, we'll pass the question mark along with the output O3. We will combine O3 and then the question mark vector representation, and we'll pass through this neural network to get an output O4. Now the output O4 will have information encoded from all the previous inputs or all the previous tokens. You see in this diagram that we are having encoded information from all of the tokens. The output O4 will have the information for the whole sentence. So this is a recurrent neural network. Basically, what we are doing is we are passing the output from the neural network to itself, and we are processing each token at a time. Okay, we are processing each token at a time, and from the previous time step. So this is like different time steps. This is the first time step 1, time step 2, time step 3, and time step 4. In the first time step, we are passing how, and we are getting O1. In the second time step, we are passing R along with O1 to get O2, and so on till we get O4, which will have the encoded information of the whole sentence. So this is the recurrent neural network. The recurrent neural network is used for sequential data, where sequence is important. And the example of sequential data is text. And we have also music or audio data, which are sequential data. And there are various other forms of sequential data, such as weather information. So for those kind of data where sequence is important, the recurrent neural network is used. So this is a recurrent neural network. To represent this recurrent nature, where we are feeding the output back into the model, we represent the recurrent neural network like this. So this is a recurrent neural network. So it looks like a feed forward neural network only, where we have input and then some hidden layer and then the output. Let's say that the output from the hidden layer is feedback into the neural network. So that's what we have seen, right? So this will be this is a loop where we are output is feedback into the neural network, and this is called hidden state. Hidden state will have information from the previous uh, time steps. So this is a basic recurrent neural network. So let's look into the internal of RNN, or recurrent neural network. In RNN, we have two inputs, as we have seen. First one is the input that we have in the data set. We have a sentence, then the current word that we are processing is the input. And second input is the hidden state from the previous time step. So we have shown the input from the current time step with xt, t represent the time step, and the second input is ot minus 1, which is the output of the previous time step or the hidden state from the previous time step. So it's ot minus 1 because this is from the previous time step. And for each of the input, you'll have w, which is the weight. And just like as we have seen for the feed forward neural network, this xt and w will be multiplied. And similarly, ot minus 1 and w dash will be multiplied. So we have two weights here because we have two connections. So both of them will be multiplied with each other, and then we'll take a sum of them. So we'll sum this. So here the expression will be xtw plus OT minus 1 W days. So here we'll sum both the terms, both the inputs, and then we'll provide that summation to the activation function. So activation function we have discussed. And after passing through the activation function, we'll get the output, which is the OT. And this OT can be again an input to another RNN. Please note that even though I'm saying another RNN or another neural network, we're using the same neural network, but we are running that with different units. We are not having multiple neural network here. We are using the same RNN. So we are having only one unit here, and we are passing different inputs to it, and we have a representation over different time steps. The looping mechanism of RNN that we saw, it helps the RNN in passing the information from previous time step. So if you have a sentence, the looping mechanism will help you to pass the information from from beginning of the sentence. And if the sequence is very large, if the sentence, or if you are using it for paragraph, if the paragraph is very large, then the RNN tends to lose some information from the beginning. We call that as a short-term memory loss. There are various types of recurrent neural networks. So we have many to one recurrent neural network, where what is happening here, we are passing multiple inputs and we are getting one output. Okay. So at first time step, we are passing this X11 into this neural network, and we get some output. We pass back the output from the one output back into the model along with the X12. Now we get another output. We combine that output with X13 and pass input into the neural network. And till we process the last input, and we use the output from the last input, which is the Y hat. So example of this many to one recurrent neural network is where we need to do some kind of classification. So given a X, we need to classify. So you don't need to get the output from each of the tokens. You can get the output from the last token. At the end of this token, at the last step, we'll have the information from all the previous tokens. So in classification kind of task, we can take the output from the last token. Next one is one to many. So given one input, it generates multiple output. So here we give X11 as input. It generated O1, and it feedbacks into the model and generate O2, and it will keep continuing till we have hit some kind of termination mechanism. So example of one to many RNN is music generation. So given a starting node, you want to generate music. So that's an example of one to many RNN. Then we have many to many RNNs, and there are two types of many to many RNNs. One is of same length, where the input length and the output length is the same. So we saw this. Basically, we input something, we get O1 output. We feedback the O1 and the second input back into the neural network. We get some O2. We'll keep doing this till we get till we have processed all the inputs. And we'll use all of the outputs. So these are used for tasks like POS tagging, where you need to tag the parts of speech for each of the word. And the next RNN is many to many with different length. So here, what will happen is that we'll have input of one length, and output can be of another length. Okay. So here we are passing X11 and X12 as input, one after the other, to this neural network, and it is producing O1, and this O1 will be feedback into this again, and then it will produce O2, and so on. Um, Here the input and output lengths are it can be different. So this kind of architecture is called encoder decoder architecture because we have two separation, right? We have two steps here. In one step, we are processing the input. This is the encoder part, and in the next step, we are getting the output. So this is the decoder part. So this architecture is also known as encoder decoder architecture. For example, for many to many RNN of different length is translation. Let's suppose you are doing some kind of translation of a sentence. If the input sentence and the output sentence can be of different length because of language difference, right? There we can use the this kind of a encoder decoder architecture. Thanks for watching. See you in the next video. Bye.